Hello and good afternoon, everybody. Welcome back to our webinar series for the Bridge to Land, Water, Sky Living Lab project. My name is Megan. I'm on the Bridge Communications team, and I will be your host for today's webinar. Before we start, as we continue to build respectful relationships, we would like to begin with a call to gather, drumming and singing by Muskeg Lake Cree Nation to appreciate the cultural practices of the Indigenous partners guiding this project. The drum is considered a connection to the natural world, and together drumming and singing are essential elements that help maintain Indigenous identity and cultural heritage. Just a quick webinar protocol. So this webinar is being recorded and will be posted to the Bridge to Land, Water, Sky YouTube channel after the webinar. There are closed captions available. They are on your toolbar, and you can feel free to enter any questions into the Q&A at any point throughout the webinar, but questions will be addressed at the end. There will be a Q&A period. So yeah, we'll go through questions then. All right. Rethinking the value of marginal cropland, Dr. Christy Morrissey will discuss how precision data can help producers better manage lands with perennial plantings and track changes in soil health, carbon storage, biodiversity, and economics over time. The goal is to provide options that maximize land profitability and productivity while capturing ecosystem service gains. Dr. Christy Morrissey was born and raised in Vancouver, and while attending the University of British Columbia, she was inspired by ornithologist Jamie Smith to pursue a career in wildlife. Following graduation, Christy volunteered for the Canadian Wildlife Service to study raptors and carbamates, which was the basis of her PhD at Simon Fraser University. Christy is currently an associate professor in the Department of Biology and School of Environment and Sustainability at the University of Saskatchewan. Christy is involved in several projects, including the Bridge to Land, Water, Sky Living Lab and Prairie Precision Sustainability Network. And I think that's all for me. So without further ado, I would like to give a warm welcome to Christy.
Wonderful. Thank you so much for that introduction. And I will begin by just also acknowledging that we are on treaty territory, and I would pay respects to the ancestors who've gone before us. So many of the things that I'm going to be talking about today are kind of a partnership between the Prairie Precision Sustainability Network and one of our key partners and the work that we're doing on the Bridge to Land, Water, Sky. There's a great deal of overlap. So I'm leaning a little bit on both projects, but will emphasize this component of the PPSN, and I'll talk more about it. So here on the prairies, we are sitting in a region that is highly agriculturally intensive. It is actually considered the most agro-intensive region of Canada, has the highest agrochemical use, so pesticides and fertilizers, of anywhere in Canada, and indeed Saskatchewan is the highest agrochemical user by province. And we're also subject to a whole bunch of climate extremes, as we know. And this region is very important for biodiversity, especially because of its wetlands or potholes that you see everywhere. So it is a really interesting region that has all kinds of complex issues that are going on. And one of the kind of patterns that we're seeing in Prairie Canada, as is going on in many places of the world where agriculture is one of the dominant industries, is that the lands that are hosting or providing agricultural cropland are becoming more intensive in their agricultural practices, both from a chemical use, but also removing landscape features like wetlands and shelter belt or trees, shrubs, any of that kind of non-crop diversity is being taken out in favor of intensifying the land and making it more, putting it under more crop. And indeed, in the prairie region, when we've mapped this and measured this over the period of 1996 to 2016, so just a 10-year 20-year span, we actually saw that there was a dramatic increase in the amount of landscape simplification. It went from 55% to 63%. Of that land, that cropland or arable land becoming solely crop, so lacking those diverse habitat features. And the reason that we are concerned about that is because many studies from around the world clearly show that agricultural intensification, which is a form of leads to a form of landscape simplification, ultimately ends up in a loss of biodiversity, a loss of ecosystem services, and usually a lower resilience to some kind of disturbance, including climate effects. And of course, one of the benefits of why do farmers even do this? They intensify the land because they can get more of those provisioning services, things like higher yields, more arable land for cash crops. But we're losing many of the other services that are important for sustaining sustainable systems. That includes things like nutrient management, water quality, availability of water, as well as some of the cultural and recreational benefits that many of the citizens, including First Nations, value. So we really need some comprehensive solutions that address this in a sustainable way. And these need to address these big questions, like how do we reduce emissions and agrochemical reliance on farm fields? How do we create more habitat for biodiversity? And how do we do all this while we still grow high quality food and not affect the bottom line or profitability of farm operators? So, of course, many of us who are in the field are really thinking about nature-based solutions that can address these big picture problems and come up with win-win-wins. Wins for nature, wins for food security, and wins for producer livelihood. Because I think when we think of this as a system, which agricultural ecosystems are systems, we have to think about all of those components. And it's not enough to just favor one over the other. For example, environment can't be placing farmers at a disadvantage. We shouldn't be choosing these things. So the idea of nature-based solutions has become quite popular, and there are lots of nature-based solutions out there that one can choose to improve the sustainability of farming here in the prairies and around the world. And some of the practices that you see on the screen here include intercropping or cover crops becoming more popular, things like longer and more diverse crop rotations, keeping those natural areas like wetlands and shelter belts, even planting or making our field sizes smaller has been shown to be a nature-based solution, and crop livestock integration, so having cattle or livestock grazing in cropland, perhaps during the off season. Now, the other one that is something that our group has been really interested in is this idea of incorporating perennials into marginal lands. So this particular solution is interesting because we're focusing on marginal lands. That is kind of a complex definition, like what is a marginal land? And we have been thinking about this quite deeply for a while, but essentially we've landed on a definition that these are areas that are low yielding, like consistently low yielding, and have low profitability for the farmers. So despite perhaps growing a crop in some years or having some productivity, they often don't pay for themselves because their input costs are higher than the amount that they get for selling that crop. And these areas are often challenging from the point of view of the producer because they often have salinity problems. Sometimes it's moisture issues, too much moisture if they're near wetlands, or too dry, perhaps on a hilly area, or some other operational factor, could be close to a road or a right-of-way. And often they look like these kind of ugly shots on the screen that we've gone out and taken pictures of. So how much actual marginal land is out there? And this is a really big question. There's not a lot of data to tell us actually how much marginal land is out there. A really old estimate from 1996 that was produced by the PFRA, or the federal government that was of the time that was running the PFRA, suggested that just due to salinity alone, there could be between 3 to sort of 52 million hectares of marginal land. And this would amount to about 6% of the farmland. They estimated that up to 4 million hectares are slightly to severely saline. And they think that this is expected to increase under climate change. Of course, when we have those hot, dry summers, then those are going to be exacerbating many of the salinity issues. Now that's just salinity, so it doesn't cover the other reasons why the land is marginal. And there isn't really good tracking of this data otherwise. So our team, as part of the Prairie Precision Sustainability Network, has been trying to figure out how much marginal land is out there. And we call this Project Marginal Land Solutions. And we're trying to find out essentially, where is all this marginal land? And to do this, we've gotten a lot of help from growers across the prairies. This is a map showing where all the growers are that we have obtained data from. So to date, we have data from over 80 different producers across the 3 provinces. And the data they're giving us is their yield data from over 1 million acres. And these are 10,000 field years of data. So many of them are collecting data on their combines about how much yield they're getting on every field. And this is very, very high resolution data. It's often down to sort of less than a meter by a meter. And so it's really detailed data, it's big data, and we're still collecting this. Now, the Prairie Precision Sustainability Network was launched in 2021, and we more recently received NSERC funding to expand this work in 2024. And the Bridge to Land Water Sky has been partnering with us for some of their fields as well. So when we think about marginal land, you often, one of the first questions I get is from general public is like, well, why would they even farm it if it's not profitable? And that is a valid question because it's not that simple. We often can map these areas, and in one year, it might look like this map here, where there's lots of red areas that would show low yielding areas, very essentially that they're actually getting negative profitability. But in another year, those areas could be profitable, or some of them could be profitable. And that could be due to environmental conditions, but it also could be due to just the fact that crop prices change every year. So when you plot sort of how much profit a given field is producing, for every one of the pixels on the left of the screen, you can sort of present a histogram of all the predicted profitability and how many acres are actually producing profit greater than 0, right? That is their amount they're receiving for the crop is more than the cost of their expenses. And everything in red on the first bar there, and essentially on the screen, are acres that are unprofitable because they actually are losing money on those pixels or on those areas. And you have to look at this again over multiple years and try and figure out what's going on. Because if you kind of compare how much marginal land there is for different crops, you'll get a very different picture. So this is an example from just one grower. I don't know if you can see my cursor, but I'm pointing to the left panel graph, which is canola. This is one grower's number of acres that are receiving profit. And everything on the right-hand side of the red line is profitable for him, for that canola. He's getting $773 an acre, and he only has about 1.5% marginal acres on that field, which is on the left of the line. So that seems like a really small amount, like only 1.5% of your acres, that's no big deal. With lentils, it actually looks like if he planted that field in another year with lentils, now he has profitability of $333 an acre. His marginal acres are about 5.5%. So it's a bit worse, basically, with lentils. And then with spring wheat, on the same field, now he's getting $463 an acre, and his marginal acres are about 9%. So you might conclude, if you're a farmer, just plant canola every year, and then that would be a way to solve all of your problems. But we all know that that's not a good agronomic practice, and indeed that can fail after a couple of years of doing that for different reasons, usually related to disease like clubroot. So rotating their crops is part of the solution, but of course, profitability and indeed marginality will vary each year. So what we want to do is really look at how much marginal land there is in a given field over multiple years and multiple crops. And so what we are doing as part of this project is we take for that data from all of those red dots, which are all the growers who have given us their acres, their precision ag yield data from their combines. Some of them give us data for a single year. Some of them have data for up to 20 years. We have small farms that are 900 acres, and we have large farms that are 45,000 acres. So huge range, but on the whole, we've got data now from over 1 million acres. And the team here at the U of S are analyzing this data. So you can see from this example, one field in 2014 was in canola, then it switched to wheat, then it went canola, then it went barley, peas, canola, wheat, barley, canola. So there's a theme here that canola comes up a lot. Why? Because it's one of the most profitable crops to grow. But we want to look at all of the profitability across all of those years and all of the marginality across each year, and then kind of combine it so that we can figure out which one of these, which areas in the field are possibly low profit, consistently low profitability, or as we're calling it, marginal. Now, this requires a huge amount of data processing, and we use machine learning models to try to deal with all of that data because it's massive amount of processing power. And ultimately, we also only have data from, those 1 million acres, but there are, many more acres that we don't have data from farmers. So we want to actually interpolate using satellite imagery to fill in the gaps. So what does this mean? We can take imagery data that's from space, that's looking down on the field that we do have data, and we can also compare that or use these models to actually extrapolate for the areas where we don't have the actual yield data, and just use the satellite imagery to sort of predict whether or not a particular area of a field is marginal or not, or low yielding versus high yielding. And so we've done this now for various regions, and we're kind of working our way to develop this across the entire prairies, which is a big job. So the goal is really to estimate how many marginal acres there are consistently, for not just on any given field, like one field for one farmer, but also across the whole prairies. And I don't have the final answer, but I can tell you that for the regions, the test region in southeastern Saskatchewan that we have done for canola and wheat fields alone, our region shows that even, while there could be, say, 10% of a given field might be marginal, overall at a regional level, using canola and wheat only, we found that 23.7% of all of the land was this stable low yielding, or classified as stable low yielding. What does that mean? Well, when we translate it into sort of economic terms, it means that there might be between 10 and 15% of the overall area that's being cropped is actually cropped at a profit loss. That is, the farmers are losing money. And that's important because, there's a huge amount of land out there that farmers are putting their inputs in, which are very expensive. And perhaps these acres are not being used optimally, and something else could be done with them. So the idea of the Prairie Precision Sustainability Network was not only to do this phase 1, where we do the big data modeling of all of the prairie region to figure out where all the marginal land is, but also to work with individual producers to try and test a solution to this marginal land problem. They can't just leave that land, so we're trying to work with them to figure out if perhaps planting these areas to perennial forages using a mixture of tame and native forages, would this be a better solution? And could this provide some additional benefits, both from an agronomic perspective, but also from an environmental perspective? So, we've started by working with farmers using something called our field profitability and marginality tool. This tool is a web-based tool, and I'm going to switch to the next slide here and just see if my animation will work. So this particular animation is just going to kind of, as I'm talking, it'll just walk you through how this tool works. We are just opening a TIFF file. The farmer gives us their precision data for multiple years. We integrate it on our computers. It's totally secure servers. And then we send it back to them as this integrated file that they can then use with our web tool. They're selecting what crop they want to test with, in this case, canola. They can select their crop price and use that slider. They can slide the expenses, so they might determine they know how much their expenses are per acre. And after they've decided on this $11 a bushel for canola, or some other number, depending on what they think they could get for canola next year, or what their expenses are, the whole map will update and change appropriately. It will ultimately give them an output as to where like a map like this, and they can see where are their marginal areas. And you can see that this particular area that we're outlining in the polygon is a possible area that they might want to do something else with. Because it's purple, that means they're actually losing $171 an acre in those kind of very purple areas. This is a fairly significant profit loss, and we can then suggest to them these acres might be better suited for some other perennial conversion or doing something else. Okay, I'll flip to the next slide. Try to stop this animation. So that's our web tool. And in working with the producers kind of iteratively, they can play around with that tool. And ultimately, we come up with these maps of their field and we locate where the marginal areas are. And it's often true that many farmers know where these marginal areas are. They're very familiar with them when they go around with their tractors, they encounter them. So often it confirms their own belief or their own knowledge. Sometimes, though, it definitely is news to them. So I think it's not true that all farmers know where these areas are or how extensive they are. We have done this for producers in Alberta, and some examples of what this field tool looks like in Alberta fields. They're quite variable. So in each case, you can see that there is areas that are the most marginal, the more purple areas, and those that are the least marginal. And then anything that's not showing up in the highlighted or in a color is basically cropland that is profitable, right? So they are earning a profit on those areas that aren't color coded. In Saskatchewan, this is what it looks like for some example fields. Depending on where you are in Saskatchewan, some of the issues are salinity or moisture issues. Sometimes they're more difficult to tell. It could be a hilly area. A hilltop is often a marginal area. And in Manitoba, I wish I'd changed this slide to show some of our more recent fields, but there's a lot of wet areas in Manitoba. And that seems to be one of the key reasons why there's marginality. And they often are working with really complex fields that have to be driven around lots and lots of curves. But here's some examples of areas that are from different fields that show the degree of marginality and the types of situations. So these are all coming from that tool, web-based tool. It's free for farmers to use, and they work with our team to kind of see where all these marginal lands are. So this brings me to the other part of my question about whether or not marginal lands have another value. Is there something else we could do with them? And part of our motivation, as I've shown in the tool, is to try to show farmers where these areas are and to kind of get them interested in thinking about solutions to convert those areas. These marginal lands basically are marginal from a crop production perspective, but they could have other value in terms of environmental benefits. If we create habitat for pollinators, for birds, for protecting or buffering wetlands, they could have production benefits. Remember that they are putting their inputs in terms of seed and chemical out on these fields. And driving over these areas with their tractors, there could be benefits if they don't have to do that in some areas of the field. And this usually leads to economic benefits simply by removing those acres out of production. The input costs go way down, and as a result, their net profitability at the field level can go up. So we've been working with those farmers who are interested in the Prairie Precision Sustainability Network and including the Bridge to Land Water Sky farmers to target these marginal patches for experimental conversion from the crop into perennial forages. So we ask them to keep a couple of the patches or one or more of the patches as business as usual or our controls. Those they don't convert. And then we've been asking them if they'd be willing to convert some of the areas into perennial forages, which would be our treatments. Now, many of these conversions actually, we believe they have potential for ecosystem service benefits. And I'm just going to show you a little bit of data from a past study because this is still a fairly new project, the PPSN, but I am going to show you data from a previous study that I did from 2019 to 2022, where we did the same thing. We asked farmers to convert, in this case, on 51 unique fields, 8 farms, the farmers converted between 10 and 25% of their marginal cropland into perennial forages. So here's some examples on the screen of how they converted them. Most of these were salinity or moisture issues. Some of them the farmer wanted to square off on the right, and on the left, they were happy to kind of contour the field, and the issues where the marginality was to sort of keep as many acres in production as possible. And we found, just as a kind of quick snapshot, bird acoustic diversity, that is the sounds that birds make, rapidly increased on our treatment fields compared to the reference fields that didn't have any perennial forages added. And this bird diversity was noticeable increase each year from years 1 to 3. So we saw a rapid, I guess, colonization by birds in these forage plantings, and there was a benefit that already occurred even in year 1, but it continued to increase each year up to year 3. And interestingly, from the producer's point of view, one of the things we found is that they didn't see any real noticeable loss of yield or profitability between our reference fields and the treatment fields. There was a very small reduction in yields on the treatment fields in our study of 9%, but they actually on average took 16.5% of the area out of production. And overall, when you convert that to profits based on their expenses being reduced, they actually saw no difference in their profitability. So that's the metric that matters the most to the producers is this profitability, not necessarily the yields. And we've been trying to emphasize that there has to be a change in their perspective about looking at these fields, that it's not just yield. They should be mostly focused on profits. So going back to the PPSN, we are now in this phase where we are working with the farmers. We have over 40 fields where farmers have agreed to convert their some of their marginal land into perennial forages. The conversion patches are shown in green, for example, and then they are asked to keep some areas in blue as controls on the same field. So we actually want to measure the impact of the forage conversion at a field level, but also we're interested in testing whether or not these forage conversions have any benefit for ecosystem services or indeed to the producer's bottom line. Excuse me. Part of our experimental design is to test different forage mixes. As you may, if you've done any kind of forage planting, you might know that most of the blends that you get out there tend to be these cool season grasses. They're usually things like brome or wheat grasses. They grow really quickly at the beginning of the season if there's sufficient moisture, and that it tends to be the mixes what is dominated, but we actually want to test whether or not the inclusion of warm season grasses, which tend to peak in production a little later in the summer, or the inclusion of legumes like alfalfas and clovers and other things into the mixes has additional benefits. So we give growers the option to plant a base blend of just 3 cool season grasses and then add 1 or 2 species of warm season grasses, 1 or 2 species of legumes, or if they were really keen, they can add both legumes and warm season grasses to that mix, and they'll have a total of 6 species in their mix. And then now teams of researchers are going to be out again this summer measuring the whole bunch of parameters, things like beneficial insects, greenhouse gases, soil organic carbon, various metrics of soil health, forage and weed production, and weed management. So we want to know how well the forages grow and whether or not they are taken over by weeds. We also want to know more about how the producers are making their decisions, what motivates them to be part of this study, what motivates them to want to convert marginal areas. And then we're also measuring things that matter to them, like the yield and profitability. And we're doing some measures of bird diversity and water quality where those fields have wetlands. Just to kind of give you an overview, these are the next two slides. I've got images from the drone footage that was done on 2 of the Bridge to Landwater Sky fields. So the drone was flown in July, and this is over the field conversion. So these fields were planted in just last year. And we used 2 of the Bridge to Landwater Sky fields as kind of our test cases, where we wanted them to plant the forage last year. It was our first ones just to test out how we do the forage planting and some of the logistics around it. But most of our fields, our 40 fields that were part of the study last year, were just in baseline year of data collection. So no conversions are happening on most of our fields. But here's just an example of, you can see how well it's growing already. There are some challenging patches that haven't grown in, but we'll be tracking that over time. This, I believe, is the Green Lake Trail, and it was a forage conversion was occurring as a strip on either side of this so-called road or trail. So you can see some green already coming up, and the new forage is actually done pretty well, because this was a super challenging area of very sandy soil that had a lot of erosion. So the project timeline is, as I mentioned, in 2025, for most of the fields, it was just baseline monitoring of all those metrics, with the exception that we did a couple of test case forage plantings. This year is a big year for us. We're doing conversion, or the farmers are going to be converting 43 fields with these patches being planted to perennial forages. And then we have an additional 20 fields that we are doing some baseline monitoring, most of which are in Manitoba, where we were missing data from last year, from our study. We didn't have Manitoba growers, so now we do. And then in year 3, 2027, there'll be marginal conversion of those 20 fields that joined just now in Manitoba, and we'll continue our post-conversion monitoring for another couple more years. Hopefully, we'll get additional funding to extend this further. Of course, adding diversity to agricultural fields has lots of benefits. As I mentioned, our goal is to try to find those win-win-wins for nature, food, and for farmers. There's a lot of benefits that can occur, and we are trying to measure or quantify those benefits. But some of them are like that field and landscape diversification. So instead of being a system that is intensified and simplified, we want more diversity on the fields. This can optimize the land use. So remember that much of this impetus is because fields are being cropped, or areas of field are being cropped at a loss. And so perhaps those patches could be better used for some other land use. In some cases, the forages will be hayed for production for the producer if they have livestock, and they could sell that hay, which will provide additional economic benefits. But even just reducing your input costs is a huge economic gain. Those inputs, such as agrochemicals, pesticides, fertilizers, are all damaging to the environment. And of course, with a reduction in those inputs, especially in many of the sensitive areas like around wetlands, we could see improvements in water quality and in improvements in soil health, as well as to bird diversity and insect diversity. We are looking at changes in greenhouse gases, And it's predicted that these areas will store more carbon. And so if we do an extrapolation, if farmers did this across all of the prairies, in those kind of 10 to 15% of the land that's marginal, you can imagine that we are already doing we would be doing a significant amount to improving greenhouse gas emissions and indeed capturing more carbon. And of course, what's close to my heart is that this will improve biodiversity habitat and beneficial species pools to help mitigate the losses of biodiversity that's happening around the world. So our team is very diverse, but is led in part by these two wonderful people. Andrea is our project manager and Tamara is the grower cooperator. If you're a producer or know a producer and want to get in touch and be part of the study, please reach out to Tamara or Andrea, and you can find how to contact them on our webpage, which is www.prairiepsn.ca. Producers are getting a compensation for this work, for being part of this study, because we know it's work for them and there's risks involved. So we generally have a signing bonus for them for that first year when we're doing sort of baseline measurements and being part of this whole process of giving us data from their combines and so on. They get a signing bonus up front. They get, after they convert those areas this year, for example, they're getting $75 an acre. And we give them their seed cost reimbursed, and they can also stack benefits with other programs like Ducks Unlimited, Ministry of Agriculture, or the watershed associations all have various incentive programs that are complementary, and we've worked with all of them to make sure that our study is well aligned. So with that, it is a bigger team than just me, and I absolutely am not the only person doing this, although I am the lead researcher for the PPSN and one of the participating researchers on the Bridge to Land, Water, Sky. Of course, these people on the screen are just some of the amazing scientists and collaborators that are working on this project, and I thank them for their contribution to the presentation, and I'll be happy to take any questions. Thank you.
That was awesome. Thanks so much, Christy. So we are gonna take over for a second here. We do have a quick survey just to fill out before we begin our question and answer period. It's important for us to hear what you guys thought of the webinar today. And it is similar. So the Q&R code is just on the screen there. That's how you can access that survey. We'll just give you a few minutes to answer the questions there. And it is similar to what you filled out when registering. So it's not the same, but it will be similar. Christy, I just want to thank you again. That was a very thorough webinar presentation. So yeah, we really appreciate that. So Clint's asking, can you account for opportunity cost analysis where you monetize the ecosystem services value, as well as say selling hay or running a nature tourism business, etc., and better yields on existing land?
Yeah, I think that is something that we are planning to do. I mean, we have economists on the team, and including ag economists. So Tristan Skolrud is on the team, and Jeremy Pittman is our social scientist, and we are trying to understand sort of the value of those ecosystem services, as well as the potential for these other, as you say, sort of opportunities or opportunity costs. I can tell you from my previous study that the farmers that hayed the areas, they all did substantially better. It's true that when I did that study, it was during kind of a drought period, and the availability of hay was limited and hay prices were going up. So they were probably an additional gain, but they made a lot of money off of those areas. So it was kind of like there were a few data points that were really abnormal. And when we looked into it in terms of their profitability, it was all because they used them more as for haying. So I think, yes, there are many opportunities for these areas to better use them from an economic point of view, and we are exploring those questions around how to better monetize that change.
Nice. Okay, we have a question here from Lydia. Is there a long-term plan for monitoring the impacts of these conversions? What benchmarks and ecological indicators do you expect to see, to be able to see in 5, 10, 15 years that would demonstrate success in this project?
Love your question, Lydia. Our funding, like everything in the research world, is not 5, 10, or 15 years. It's only 4 years, like, well, 5 years basically we get funding, but many of them are shorter. They're 3 or 4 years. And these kind of studies take a long time to see the full benefits. I know that we've chosen indicators but from both biodiversity and soil health indicators that have shorter time spans, partly because of the funding being short. We need to see something early. Like I said, for the bird work, I expect that we would see changes in bird diversity that are positive even within 1 to 2 years. But things like greenhouse gases and carbon sequestration, those take longer, and that could be more like 10 to 15 years. We hope to have funding or additional funding to kind of look at some of those markers that would be important to see longer term. And we are collecting some of the data for the soils that would allow us to do that, in future. So hopefully we will have the early, the first years, and then we hopefully can come back and revisit those indicators for future years. But it's a great question.
Yeah, for sure. Okay, so are you accounting for grazing management at some level?
So the answer right now is not yet. It's going to be interesting what these producers do. We are asking them to manage those areas, with some advice, but to the way that they would like to manage them. So they have a choice to graze them or hay them, for example, in future years. We only restrict them from haying and grazing in year 1, particularly grazing. They might be able to hay them in year 1, but grazing is kind of off the menu because they can basically could damage them, and then that's not great for everyone. But otherwise, they potentially will gather those additional benefits. But we've heard one of the things that we are doing is we're not prescribing exactly which species they plant. So I went through sort of the forage experimental design, and they're planting cool season grasses and either warm season grasses or legumes. A lot of that is dependent on what they're going to use the forage for. And we do have a few who want to do things like additional pollinator or flowering species because they just want some of those so-called recreational benefits or cultural benefits. So we are providing enough flexibility that they are customized to the growers' interests and what they want to do with them. That does create variation, and it's harder to study scientifically, but this is in part why we on every field have a control and a treatment area so that we can kind of look at the change at a field by field basis.
Nice, very interesting. Okay, so we do have someone that has their hand raised. We're just going to allow mic access so you can ask your question. Just 1 second. Okay, you should be able to unmute yourself now.
Is this
This is
Daryl, I
Daryl.
think? Okay.
We'll give you a minute or two.
And if not, I think there was one question from Julie on the other chat.
Oh, yeah. Okay. We'll check there too. Oh, yeah. Okay. Okay, I think we'll move on. If we get it figured out, Daryl, maybe we can try you again in a second.
Oh, yeah,
Oh,
he's just Daryl's
I
put
see you in
something
the
in the
chat.
chat. Are you able to unmute Daryl? If not, you could always just put your question in the chat or your
Just write
comment
it.
in the chat.
You should have a little mic on the top corner of your screen, the top left, and you should, if you just click it, it should unmute you. It says mic. You can also, I think maybe we'll go to the next question. And you can write your question in the chat perhaps. Okay, so we'll go to Julie. On the slide with the SK002 field, it was interesting to see 2 drained wetlands in the middle of the field with the evaluation to what was marginal. Were these areas deemed marginal as they were in the field, or was the whole field just seeded with the project?
I think what you might be seeing, Julie, is just wetlands that have dried, not rather than being drained. So it's just later in the summer, and so they weren't actively drained. We don't include, so our mapping of marginality is only on acres that are in crop. So if the farmer has left certain areas uncropped, including wetlands. Often there's, field edges. I don't want to call those margins, but, the field edges or road right-of-ways could be treed areas. Those are not used in the calculation or the estimation of marginality because they're not actually cropped. So we only take the acres that are actually under production. And then from those, we look at their precision yield data to inform whether or not they're low yielding over multiple years. So those wetlands would not have been included because they're not actually cropped. And we ideally would like them to keep them there, right? Like those are already protected. It's possible, however, that what we see really commonly is rings around those wetlands that basically the farmer is planting the crop too close to the wetland. And those are often unprofitable. And so we're seeing that over and over and over and over again. And that's just a symptom of the fact that many farmers are trying to maximize yield by increasing the area that they're planting, but they're not getting a lot for doing that. They plant too close to the wetland. The soils there are either waterlogged or saline, and they get very low yield in many years, and in which case can show up on our maps as being unprofitable.
Awesome. Okay, Daryl, we'll go back. We have your question here in the chat. Have you looked at have you looked at policy options that might enhance your initiative? In particular, if marginal, ephemeral wetlands lands were not taxed, they would be more attractive for conversion to dedicated biodiversity areas.
I love the way you think. I'm not a policy expert, but I think about this a lot. And one of the key things that is, something that bugs me a lot is that all land, in terms of our land taxes or our property taxes, if you get a land assessment done on your acreage, what they call sloughs and wetlands and kind of forest areas or bush, those are all valued as $0. In other words, they have no value according to the land assessment. The reason they do that is to prevent those areas from being taxed. But what tends to be interpreted is that, well, if I can just convert them into a crop, I can get so-called value out of them. And often they can actually escape being taxed for 5 years between assessments. So they could, because they don't get assessed, every year. And so there is kind of a perverse incentive there to convert those areas. And that, I think, needs to be addressed. There is some discussion with crop insurance to provide positive incentives through policy, through crop insurance policy. That is, if you don't crop these marginal areas, or indeed if you take them out of production, they'll give you kind of discounts on your crop insurance or some other kind of benefit. And then right now, the provincial governments, at least for Saskatchewan and Manitoba, they have programs that try to give funding for producers to convert, well, not just, they don't call it marginal land, but they just, any lands back to grasses or tame or native grasses. So you can get reimbursement of seed costs, you can get payments for that. And they're pretty generous, actually. I think there's one that's a pollinator one, and they'll give you $50 an acre, and I think it'll only cost like $7 an acre to actually do it. So they're trying to really incentivize these in a positive way, rather than using the policy stick to prevent people from doing it. The bad things, they're trying to encourage the good behavior. And you had a question about native forages. We are including some natives on our list. We have like a big species list. So producers can choose natives. Many of the warm season grasses that we're encouraging are natives. And we are kind of against using all natives because they're really not always best suited, or they're very hard to get seed for, or very costly. So it's probably not practical, but there are many excellent native species that we believe would add not only diversity, but provide some of the benefits. For example, having deeper roots, longer growing seasons, greater biomass over the entire season, and drought tolerance, et cetera, that I think many of those natives, or inclusion of some natives, will have additional benefits to these what are challenging environments. As a side note, I'm having my students in my undergraduate class do a little experiment, and they're planting 3 different grass species right now in saline and normal soil conditions through this as a project, as a class project. And we're including some native species as well. So we're testing their suitability. So yeah, lots of exciting things in that area.
Nice, very cool. Okay, so we are at 2:30. Of course, if anyone needs to leave, this will be on our YouTube page by next week. But there are 3 more questions here in the chat that I think we'll go through, as long as you're good with that, Christy.
Sure, I can stay for a few more minutes. Yep.
Okay, we'll go through these ones then and wrap it up. So Trevor's asking, with respect to producers' motive, we have found producers are concerned with herbicide resistance on these areas with kochia and foxtail barley. Seeding to forage to lower expression of these weeds has been a great selling point for this practice. Have you seen the same?
Yeah, it's a good, so I don't have the producer motivation data yet. Like, our plan is we've got a survey that's gone out to a wider group of farmers, not just our farmers, but definitely in talking with our group of farmers, this is just kind of, I don't have actual data on this, Trevor, but kochia and foxtail barley, the weed issue is one of the motivators. It's not the only one, but it is one of them. I think, it's kind of a combination, what you're talking about. Those are often species that are, herbicide resistant, And there's, obviously growing concern about those herbicide-resistant weeds in the community at writ large. So I think that message is getting across, but also these are often saline tolerant, like the foxtail barley, and it's just kind of an indicator of their salinity problem. And the salinity problem is definitely a motivator for many of them to address. But we'll collect that data, I think, is really the main thing. We'll hopefully see whether or not that is the primary motive.
Mm-hmm. Okay, from Clint, developing a product that could be reverse engineered to predict loss of profitability in a field if certain lands were to be converted to monocrop from current uses or habitat, etc. What if I drain that wetland or remove a shelter belt or permanent cover area?
Mm. I think what you might be talking a little bit about is some of the tools that excuse me, Ag Canada produces, like the HOLOS model. HOLOS right now is focused initially on greenhouse gases and what would be the outcome if you did practice A or practice B, but they are building in some other additional tools around shelter belts and wetlands and other kind of more sustainable practices and what impact that would have on the overall ecosystem services, including greenhouse gases, but also they're thinking about biodiversity and other things too. So I think there are people who are thinking about that exact product that you're talking about, Clint. So there isn't one that exists as far as I know right now that's working for farmers to just use, but I think there is work in progress to develop those as part of the HOLOS model and perhaps other ones out there that I don't know about.
Nice. Okay, and one last question from Brian. What have been the main reasons for relatively high rates of producer participation in sharing their data?
Oh, yeah, I mean, the data sharing is a really sensitive topic, and we got a dose of reality working with some of our Manitoba growers about, the general suspicions around sharing data. And we take that really, really seriously. We have data sharing agreements with the producers, and in it, we explicitly detail who can see it, where is it being stored, everything. So we have a data management librarian here at the U of S who's helped us to develop that data sharing agreement and indeed to make sure that our data management protects these growers. Increasingly there is risks out there, like this data is potentially, going to the big cloud, and the cloud is going to use this data usually for large companies to make more money. And we are not interested in selling this data or doing anything to the like. In fact, our entire model is based on producing tools and products that will be free to the growers. So right now we have it all protected so that the growers who are involved in the study can see the maps themselves and play around with it. It's not widely shared. The only one I showed you on the website or on our just diagram here is one that the producer agreed to, like he was happy to have it shared. But otherwise, it's really an important thing that we try to keep that secure and not share it widely. But I think there are companies that are chasing us who are wanting to do some of the same types of things, and I can't say for sure forever that this will forever be protected. And a lot of those John Deere, Case New Holland, big manufacturing machinery, they have platforms that are collecting that precision yield data automatically off the combines without their permission, really, or maybe they don't really know it, but they're already collecting it. trying to do similar types of things to look at profitability.
That's very interesting.
Yeah.
All right. I think that will wrap it up for today. If you do have any other questions, feel welcome to contact Bridge to Land Water Sky at gmail.com, and we can pass along the question to Christy. Otherwise, thank you so much to everyone who joined today, and the recording will be up hopefully tomorrow. So that's all. Thanks, Christy, so much. We really, really appreciated you coming today. And I know I learned something, and I'm sure everyone else did as well. So thank you
Much
so much.
appreciated for the audience.
Yeah.
Thanks a lot, Megan, and for Maddie for your help in promoting it, and for
For
everyone
sure.
for coming.
For sure. All right. Have a
Bye
great
for
day,
now.
everybody.